Hi, everybody. Professor Ken here, and I'm going to go over today's lesson one more time. Because I think a lot of you were focused on the quiz and maybe you didn't learn everything you needed to learn. I suggest when you watch this quiz, you pause it many times. You can take notes and you can practice. And hopefully by the end, you'll have more skills. All right, thanks. Start with the share. Okay, and I'm going to turn off the computer so it doesn't get in my way. Okay, so let's begin with the function s of t, which is position as a function of time, equals negative 16 t squared. The reason why we use t is because it's time, plus 60t plus 40. Okay, we know that's a parabola, and we know that whatever we plug in t, wherever we plug in t, it's going to give us the position. We also know that if we plug in 2 points, we'll get 2 points on the parabola, and with that we can make a secant line, but I'll get into that a little bit later. All right, now when it comes to lines, the first thing we want to talk about is the slope. So the formula for slope is y2 minus y1 over x2 minus x1. And I hope you could see this okay. Now, suppose we wanted to find s of 1. S of 1 is going to equal negative 16 plus 60 plus 40. 60 plus 40 is 100. Minus 16 is 84. How about s of negative 1? Well, s of negative 1 squared is 1. So we get negative 16 minus 60 plus 40. Negative 60 plus 40 is negative 20. Negative 20 minus 16 is negative 36. So over here, here's the x-axis, here's the y, here's 40, and we know it's going down. So negative 1, negative 36 might be here, and 184 might be up there. So it looks like it might be going something like this. We don't know exactly, but that's okay. But we do know we have these 2 points, and we know we can make a secant line through those 2 points, and we could find the slope of the secant line. So if we wanted to find that slope, we would say m equals y2 is negative 36 minus 84 over negative 1 minus 1. So that would equal negative 120 over negative 2, which is 60. And we would expect the slope to be positive because if you look over here, it's definitely a positive line. All right, now there's other ways to express the y values of a point. So we could say that it goes through the point 1. Instead of saying y, x and y, we could say x and s of x. We could say a and s of a. We could say b, s of b. So in this case, if we were to look at this point, make notation, in this point, we would say that m was equal to y2 is s of b minus b over s of a minus a. Now, it does scroll down. Hallelujah. All right, so there's our graph. All right, and that would give us the slope value. Now we know we have one point that's a comma s of a, and we have another point that's b comma s of b. All right, we learned before that if we're going to use this point slope formula for a line and want to find the equation of a line, we can say that y minus y1, that's any y value, from a point y1 equals m times x minus x1. All right, but since we're using a and s of a notation, for this we would say y minus our y1 value would be s of a equals m. Now, instead of writing this whole formula, let's just write the m times x minus, and our x1 value here is a. So that would give us the equation of the line. Okay, what we're going to do now is apply it to desmos. But before we do that, I want you to make sure that you understand that this is the formula for slope, and this is also the formula for slope. This is the point slope formula for a line, and this is also the point slope formula for a line. So you might want to write those down because I will be using those once I get into the desmos. Okay, now we're going to desmos. All right, so if I write S of t equals negative 16 t squared plus 60t plus 40. Okay, I'm going to go to my little wrench over here, and I'm going to let my smallest x value be negative 2, and my largest x value be 5, and my smallest y value can be negative 10, and my largest y value might be 80. Let's see. It can be more than that. Let's say 150. Let's say 140. That looks good. Okay, so there we have it. Okay, now I'm going to pick 2 points. Let's say we want to find the slope of the secant line at where t equals half and t equals 2. So we'll have s of 1 half is equal to 66, and s of 2 is equal to 96. So if we wanted to find the slope, which we could call m, we would say m equals y2 is 96 minus y1 is 66 over x2 is 2 minus x1 is 1 half. And we see the slope is 20. All right, now we want to use the point slope formula for a line. So I'm going to just quickly write it in what it is using quotes. Just this is a little notation. So we have y minus y1 equals m times x minus x1. Okay, so there's our formula. It didn't put it in quotes. I'm not sure why, but that's okay. There's our formula. So in case we need to look back at it, but don't add the sliders. So now we can plug in our values. We say that, notice I have the m here. I'm just going to leave it as m because we don't have to put in value 20. It'll just stay with it. Y minus our y1 value is over here, 66, equals m times x minus, and our x1 value is 1 half. Close parentheses. And we see that our secant line goes through our 2 points, and the slope is 20. So that means the average velocity from time t equals 1 half to time t equals 2 is 20 feet. If we were in feet per second, we'd be saying 20 feet per second. All right, but now I want to show you how to do this with sliders so that we can do it for any point. So I'm going to clear all this out. Okay, so the first thing I'm going to do is put in the points A, comma, S of A. Hit enter and add the slider. Now I'm going to do the point B, comma, S of B. And I'm going to add my slider. Okay, now I'm going to take this and slide it over here. And we could see that it moves the point. And what's nice is we can grab these points and move them anywhere we want. All right. Now, how do we calculate the slope of the secant line between the 2 points, which is also the average velocity? Well, we know that m is going to equal, it's going to be the y2 minus y1, but in this case, it's going to be s of b minus s of a. So s of b minus s of a. And I'm going to put the whole thing in parentheses so that I can divide it and say over b minus a. Now, that's the last time we're going to have to use that formula, because from now on, we'll only use m because we said m equals. So we can see that this secant line would have a slope of -6, which means the average velocity from 0.4 seconds to 3.7 seconds is -6 feet per second. Then if we want to find the equation for the secant line, we know it's y minus y1. But instead of y1, we'll call it s of a equals m times x minus a. And there it is. Now, here's the beautiful thing. We know that s of a, let's label it. If we put in labels, we'll know these. Okay, we know that s of a is equal to 62.191. We know that m is equal to -6.096, and we know that a is equal to 0.416. So the equation for this line is y minus 62.191 is equal to -6.096 times x minus 0.416. But as we move these points, it's going to change the slope, and it's going to change our a, our s of a, b, and s of b. Watch this. So we could do it with the slider, or we can do it by dragging. All right. So now I want to know, what's the average velocity from 0? So let's let a equal 0. And if we click over here, it puts it back into slider there to 3. So let's let our b value equal 3. All right. So here's our 2 points, 0, 40 and 376. We see the slope is 12, which means that the average velocity from 0 seconds to 3 seconds is 12 meters per second. And if we wanted the equation for the line, it would be y minus 40 equals 12 times x minus 0. I hope you're following that. All right, now we're going to take it one step further. Every point on a curve also has a tangent line, and a tangent line is the line that just kisses the curve in one point. The slope of the tangent line is equal to the instantaneous velocity at that point. So let me turn off this graph for a second. And if I bring this up here, we see that we can have a tangent line that goes like this. It'll kiss this point. It'll kiss the curve just at that point. And whatever the slope of that tangent line is, that's exactly how fast the ball is going at this point in time. So suppose we wanted to know how fast was the ball going at 1 second. So we'll let a equal 1. Now, we see that if we let b over here, the average velocity is -4. But what I want to do is take this point and get it as close to 1 as we can. So this way, it'll look, if the points are almost on top of each other, we'll have the closest thing to a tangent line. So that doesn't really look like a tangent line. That's a little closer to a tangent line. That's a little closer. We'll go like this. If we put it right on top, it doesn't exist. But when it's that close, it almost looks like the line's just kissing it right here. And look at the slope, 28.68. That's when our B value is 0.957, but let's make our B value 0.99999. 2 decimal points there. Now our slope is 28.00016. What if we let our B value equal 1.00001? Then it's 27.9998. So if we estimate as to what the slope looks like a teeny little bit before and after the point in question, we would see that it's about 27. So we would say the instantaneous velocity can be estimated to be about 28 feet per second, because we will just estimate that. Okay, what do we think the instantaneous velocity is at 2 seconds? Well, we see it's not very steep and a little bit negative, so it's going to be small and negative. So let's let A equal 2. Now we have a secant line. If we bring it really close to 2, we see that it's just about kissing the curve right at where t is equal to 2. And what's the slope? Negative 2.88. So let's get even closer by typing in the B value. First, let's let B equal 1.999. And we see that it's negative 3.9984. Then we'll let it equal to 2.0001. Oh my goodness. It's negative 4.0016. So we would say the instantaneous velocity at 2 seconds would be about negative 4 feet per second. So here's what I'm going to do, and this is wonderful for you guys. I'm going to save this. Oh, I need to log in first. Okay, I'm logged in. I'm going to save this as secant and tangent lines. And now you can use this as a little tool. I'll send you the link, because if I go over here, it gives me a link. I'm going to send you that link, and you can use this to help you answer the questions for the homework. So the other thing that will be helpful is there's going to be times where you're going to have to make a table. So let's add a table. And instead of x1, we'll call it t. Instead of y1, we'll call it s of t, and it should work. 0. Oh, what happened? S and t can't be defined in terms of each other. All right, so let's not do that. Okay, I think you're going to have to make tables, so you just have to plug in the values, but that's okay. All right, so I hope this helps you. I think the link is going to help you a lot, and I think this video is going to help you a lot. All right, so this is Professor Ken signing off. Have a great weekend, everybody. Okay, I'm ending the video.